standard form of graphing vertex or graphing equations is a little bit different than vertex form. There's a lot of steps to it. So first, let's go over what the different parts of the equations mean. So what standard form is y equals ax squared plus bx plus c. When a is greater than 0, it's going to open up, and when a is less than 0, it's going to open down. The axis of symmetry, like we did in the last lesson with the vertex, is negative b over 2a, and that's also going to be the x-coordinate of your vertex, negative b over 2a. Your y-coordinate is just like it also was, where you're going to plug in for x, and the y-intercept is your c value. So that's something that's new, but a nice way to check your graph. Okay, so here are the steps to graphing standard form. Find the vertex. And remember that that's an xy ordered pair. Step 2, graph the y-intercept. And the axis of symmetry. Axis of symmetry is AOS. Sometimes you won't be able to graph the y-intercept because it'll go off of your graph, but if you can, put it on there. Plug in and find one point to the right. One point to the right. Then reflect that point over the axis of symmetry. Then we want point 2 to the right. And we want to reflect that. Okay, so there are 6 steps to this. It's a little bit long, but once you get the hang of it, it's pretty easy. Okay, so let's try an example. So first thing we want to do is we want to find the vertex. So remember that vertex is negative b over 2a. So in our case, we already have a negative 4. So the opposite of negative 4 is positive 4 divided by 2 times 2. So 4 over 4 is 1. So 1 is the first part of my vertex. So then I need to plug that back in. So I have y equals 2 times 1 squared, 4 times 1 minus 2. So I have 2 minus 4 minus 2, which is going to give me negative 4. So that's the other part of my vertex. I can go ahead and graph that over 1 and down 4. Remember that your axis of symmetry is at x equals 1 because that's the negative b over 2a. Okay, so there's your dotted line. So now our next part is to look and see if we can graph the y-intercept. Well, the y-intercept is your c value. So the c value in this case is y equals negative 2. So on our graph, I go to negative 2, and that's where it hits the y-axis, which will actually probably end up being another one of our points also. Okay, a point to the right. So my first point to the right. So if my vertex is at x equals 1, a point to the right is going to be at x equals 2. That's directly to the right of that. So I'm going to plug that into the equation. 2 times 2 squared, 4 times 2 minus 2. So that's going to give me 2 times 4 minus 6 minus 2. So I have 8 minus 6 minus 2. I did math wrong. 8 minus 8 minus 2, so that's negative 2. Okay, so we plugged in the point 2 and got back the point negative 2. So 2, negative 2. So we graph that over 2, down 2. Okay, so then we reflect it across the axis. Well, that happens to be our y-intercept, so we don't really, all we're doing is checking it. We're 1 away here, 1 away there. So we know that that's right, and so to label that, that's the point over 0 and down 2. Okay, so now we want to go 2 to the right. So again, our vertex started at negative 1, or at positive 1. So now we're going to go 2 to the right of that, which is at x equals 3. Plugging that into our equation. 2 times 3 squared, 4 times 3 minus 2. So that's 2 times 9 minus 12 minus 2. So 18 minus 12 minus 2. And that's going to give me 4. So you plugged in 3, you got back 4. So it's the point 3, 4. So I go over 3 and I go up to 4. Reflecting that point, I'm saying I'm 2 away. I'm going to go 2 away over here. So that point is at -1, 4. And the last thing is to connect your dots. Okay, this is called a parabola. So there is your parabola. Also to be called a quadratic graph. All right, so let's look at another one of these. So first thing you need to do is find your vertex. So -b over 2a. So it's already a -6. So it's 6 divided by 2 times 1, which is going to give me 3. So that's the first part of my vertex is 3. And what you also know is your axis of symmetry is going to be at x equals 3. So I can go ahead and put my dotted line going through there. Plugging that back in, I get 3 squared, 6 times 3 plus 12. So I have 9 minus 18 plus 12, which is 3. So that's the ordered pair, 3, 3. So our graph is over 3 and up 3. Okay, so then I want to point to the right. Well, if you want to point to the right of that, you're started at x equals 3, so directly to the right is going to be at x equals 4. So I plug that in, and I have 4 squared, 6 times 4 plus 12. So 16 minus 24 plus 12 is going to give me 4. So that's the point 4, 4. So 4, 4. Put that on your graph. So to reflect that point, I'm saying, okay, I'm 1 away, so I'm going to go 1 away on this side. And that's the point over 2 and up 4. Now I want to go 2 to the right. Well, 2 to the right is going to be plugging in 5 for x. So now I have 5 squared -6 times 5 plus 12, which is going to give me 25 minus 30 plus 12, and that's going to give me 7. So we plugged in 5, we got back 7, so over 5 and up 7. Reflecting that, I'm going to say I'm 2 away. I want to go 2 away over here. So that's 1, 7. Last step then is to connect my dots. My quadratic graph looks like that. All right, so then one more that we can look at of this. This one does not have a c value with it. So we forgot to say what our intercept was on this. This one should be at y equals 12, which is off of our graph, so we don't need to graph that. This next one doesn't have a c value, so you want to add a c value of 0. There's different ways you can do that, but if we're going the same pattern that we've been, this is what we want to do. So to find our vertex first, -b over 2a, so -4 divided by 2 times 2, -4 divided by 4 is -1. So -1 is where a dotted line is going to be. That is our axis of symmetry and the first part of our ordered pair. So then you plug that in. 2 times -1 squared, 4 times -1. So that gives me 2 minus 4, which is -2. So my vertex is 1, -2. Go ahead and put that on your graph. Our y-intercept on this is at 0, because that's our c value. There is no c value, but I can still graph the point y equals 0 right there, and that'll probably be one of my points. So my next point to the right, if we started at -1, is to go to 0. Well, if you plug 0 into this, you get 2 times 0 squared, 4 times 0 plus 0, which is 0, and that's the point 0, 0. So that happens to work out being the same point. So if we reflect that, we're going 1 away, we're going 1 away here. So that's the ordered pair, back 2 and up 0. Okay, so now we want to go 2 to the right. And to go 2 to the right, if we started at -1, puts us at x equals 1. So I'm plugging that into my equation. 2 times 1 squared, 4 times 1 plus 0 is going to give me 2 plus 4 plus 0, which is 6. So we plugged in 1, and we got back 6. So over 1 and up 6. And our reflected point is, say, I'm 2 away. I'm going to go 2 away on this side, which is the point -3, 6. Last step is to connect our dots. Make sure this is U-shaped and not V-shaped. It shouldn't be an absolute value graph. It should be a quadratic. And that's all there